Hi, Chemistry 20. Today I want to go over just a couple of gas law examples to give everybody the opportunity of being really good at it. So I've set one up here. Okay, I'm saying a tire filled with compressed air is a volume of 10 liters. The pressure inside is 240 kPa, 20 degrees Celsius. Now I'm asking, what's going to be the volume of that air if it escapes the tire and into the environment with a pressure of 100 kilopascals? But check it out, it's the same temperature. I already have it circled. And we'll discuss what that means. What I always do is I just hit all of these examples with the combined gas law because it never fails. When the temperatures are equal on both sides, you just cross off that T. And maybe you just are okay with saying, hey, temperature is constant, I'm going to use Boyle's law. Perfect, fine. You can skip straight to this step. But I just like using the combined gas law. All right, so here we go. I don't think this will be too bad. The original pressure is 240 kPa and the volume's 10. It escapes to where we have 100 kilopascals and we'll find the final volume. Now I want to point out the only time units are crucial is when temperature is involved and you need Kelvin. You can use any units you want for pressure and volume as long as they match, okay? So I've got kPa on both sides. That means it's going to work. But the other consequence is I'm using liters as V1. That means that V2 will come out as liters, and I really do need to see those units in your final answers. Okay. Speaking of final answers, we'll get this one really quick here. Sorry, guys. All right, so just solving that equation there, multiplying the left, dividing what was on the right, I get 24 liters. Okay, I got another one for us. So this time I'm saying a balloon is filled with 6 liters of helium. It's at SATP. I'm going to have to remember what on earth that means. It's let go. It rises to a height of 8 kilometers. I've given the temperature and pressure at that altitude. Okay, negative 29 degrees Celsius, 34 kilopascals. So, just a reminder about SATP. That is pressure of 100 kilopascals and a temperature of 25 degrees Celsius. Okay, that's a definition of SATP. Now I'm ready to at least consider solving the problem. However, we've got temperatures this time. Nothing stays constant. All right, so we need our temperatures in Kelvin, which of course you add 273. So that 25 degrees Celsius is going to become 298 Kelvin. This guy here, call it T2. I'm just going to add 273. I get 244 Kelvin. All right, so let's put in our values. The original pressure, SATP, is 100 kPa. Original volume is 6 liters. And we're starting at 298 Kelvin. Final pressure is 34. We're looking for the final volume, and it ends up with a temperature of 244. All right, what I'm going to do is do all this math first. I do 100 times 6 divided by 298. I get 2.01. And I'm going to divide these guys, 34 divided by 244. But just a heads up, however you want to do your algebra is up to you. Okay. So 34 divided by 244, I got this 0.139. Now it should be pretty clear. We just have to divide these guys to get our final volume. Now I've only written down a couple of decimals, but when I'm doing my calculation. I'll show you. I am writing them all down. Okay. So I get an answer of 14.449. I'm just going to call that 14.45. Or 14.4 is sufficient. That's what I'm looking for. Okay. Units are important. We use liters here, so we get liters here. All right, I hope this helps you guys. Good luck.